Hi students, today we are going to discuss the elasticity. So this is one of the important topic for IIT JEE NEET. Elasticity. First you have to understand about rigid body. What is meant by rigid body? A body is said to be rigid if the body relative position of particles remains unchanged after the deforming force applied to it. Let us consider a rigid body having some number of particles. Those particles relative motion remains unchanged even though the deforming force is acting on it. The relative position of the particles remains unchanged. Then the body is said to be a rigid body. What is meant by deforming force? Deforming force means whenever we apply the external force to change the length, volume, shape of the body. Length, breadth or shape, volume of the body is called deforming force. So there is one body. An external force is acting. So thereby the length or maybe volume or shape may change. Then the force is called deforming force. Velocity. Let us consider a body. Now when a deforming force is acting on it, thereby the shape of the body or the size of the body changes. Then after removal of deforming force, it regains its original position. Then the body is said to be in a elastic nature, or the property is called elasticity. Now I am giving the definition of elasticity. Elasticity is the property of a material of a body by virtue of its shape or size may change due to deforming force. After the removal of deforming force, it recover its original state as soon as. So then the property is called elasticity. And next we have perfect elastic body. Perfect elastic body means whenever we give a deforming force, the body should changes its shape or size, and after the removal of deforming force, then body regains its original position. So the example is Here there is example putty. Next quartz. Here putty it is not a perfect, but there is a quartz. Quartz is the good example of perfect elastic body. So we can take as the example of perfect elastic body is a quartz. Quartz is the one of the example. And next, what is mean by plastic body? Plastic body means a deforming force is acting on the body. The body does not changes its original state after the removal of deforming force. So then the body is said to be plastic body. The property of a body, of material of a body which does not regains after the removal of deforming force, then the body is said to be a plastic body. Example is a putty. Whenever we apply the putty to a wall, so it gives particular shape, but it does not regain its original state. So that is the one example of plastic body. Now we have a restoring force. A restoring force means whenever any external force is acting on any body, then the internal resistance is opposing the deforming force or external force. So the force is refers to the restoring force. Restoring force means whenever we apply external force on any body, that can be produced as the internal resistance force on the deforming force, then the force is said to be a restoring force. This restoring force developed by the internal resistance due to intermolecular forces. Intermolecular forces between the molecules. Now we have stress. What is meant by stress? A restoring force is acting per unit area of the body is called stress. So there is a restoring force acting on a body per unit area. So whenever we give a deforming force, there is a restoring force is developed inside a body per unit area. So then that is called stress. So stress is equal to a restoring force by area. So stress is equal to F by A. Here CJ's units are dynes per centimeter square. SI units are Newton per meter square. And dimension formula is ML T inverse 2 by L square. There is LL cancel. Therefore ML inverse T minus 2. This is the dimension formula of stress. Now we have types of stress. We have longitudinal stress, bulk stress, shearing stress. Now I am going to give about longitudinal stress. Longitudinal stress means whenever the deforming force is acting on the body, so the length of the bodies may change per unit area. So longitudinal stress means whenever a deforming force is acting on any body, the length of the body may change. Here longitudinal stress are again two types. One is tensile stress. Another one is compressive stress. Now I am giving diagrammatically about tensile stress. A string is suspended over a pulley, one of its end fixed to the rigid support, another end is suspended to a block of mass m. So a deforming force is acting, there is a restoring force is developed, then the length of the string may increase. That is called tensile stress. And we can also take one more example. There is a long rod, we given a tensile force means deforming force on it, thereby the length may increase, the length of the body may increase from the original, then the body undergoes to tensile stress. Now we have compressive stress. Compressive stress means the length of the body should be decreases. Compressive stress. When a deforming force is acting, means the restoring force is acting on any body, thereby the size of the body may decrease. Let us consider one of the body of its original shape or size is looks like this. After applying the deforming force, the body undergoes to decreases or compress or decrease in the shape or the size of the body is called compressive stress. There is a length is decreases from the original length. Even in tensile stress, the length increases. See, we applied force, then what happens? Length increase. This the original length is L and increase in length is delta L. Whenever we give a deforming force or a restoring force. So this is the tensile stress and this is compressive stress. And next we have volume stress. Volume stress means whenever a restoring force is acting on every point on the surface of the body, thereby the value may be decreased. If you take this is one of the body, we given deforming force in all the surfaces, then the value may be decreases. So that is called volume stress, or another name is called bulk stress. Bulk stress. Bulk stress means the restoring force per unit area is called bulk stress. And next, shearing stress. Shearing stress means the force is acting on any body parallel to the surface of a body. Let us consider a block of body. We given the force parallel to the surface, that is deforming force, then the shape or the size of the body should change partially on sideways parallel to the surface. So we can say that the restoring force acting on the body parallel to the surface per unit area is called shearing stress. So here shearing stress is equal to a restoring force acting parallel to the surface per unit area. So that is called shearing stress. Breaking stress. What is meant by breaking stress? Breaking stress means whenever we apply the stress on any body, then the body should fracture. For example, a wire. We applied a deforming force on this wire, so it should fracture. The stress is acting on the body, then the body undergoes to fracture. So this kind of stress is called breaking stress. So breaking stress is equal to force by area. So same that of all the stresses, but it is a breaking or fracture of any body, that is called breaking stress. In breaking stress, here F is equal to mg, mass is equal to density into volume, but volume is equal to area into length. So we can write rho AL, F is equal to rho AL into G by A, therefore AA cancel, therefore only F is equal to rho AL G. Now breaking stress is equal to F by A. F is rho AL G by A. Here AA cancel, therefore breaking stress is equal to rho LG. For example, there is a wire is attached to the rigid support of its length L and density of the wire is rho. Under gravity, so weight of the wire is acting downward, so mass of the wire is rho. Then we can write the breaking stress when we give some force on it, so rho LG. Okay, this wire is rotating horizontally with the angular velocity omega. Therefore the breaking stress is equal to m omega square into L. There is a breaking stress omega square L, and there is a area is A. So we can say that breaking stress is equal to m omega square L by A. How do you get this equation? Is F is equal to mv square by R form. F is equal to MER square, that is F is equal to mr omega square, where R is equal to length of the wire. So mass of the wire, angular velocity of the wire. So we can write breaking stress. If the wire is rotating or a body is rotating horizontally, we can calculate the breaking stress of that rotating body, m omega square L by A, area of cross section A. Now we have strain. What is mean by strain? Strain means whenever we apply the deforming force on any body, the body undergoes to strain, means change in its length or in volume or in a parallel ways. So that means the change in configuration. Here we can write strain is equal to the ratio of change in dimension to the original dimension of any body is called strain. Here strain has no units. So strain has no units and no dimensions. It is a ratio. We have some types of strain. One is longitudinal strain. The next one is volume strain. And third one is shearing strain. The volume strain we can also call hydraulic strain. Hydraulic strain. Now I am going to give the detailed information about types of strain. We have longitudinal strain. Longitudinal strain. Let us consider a wire of length L, which is fixed to the horizontal, that is in a vertical position, horizontal level. Now we given the some force, deforming force on this wire, then what happens? The length may increase. So that is the delta L from the original length. So we can say that longitudinal strain is nothing but the change in length to the original length. Longitudinal strain is equal to change in length to the original length. We can also write this is elongation. So change in length, another name is called elongation by original length. So this is the longitudinal strain. Next we have volume strain. Let us consider a toy, that is the doll. We given the deforming force on all the surfaces, then this toy get into decrease in size or shape, almost of the volume, decrease in volume to the original value. So that is called volume strain. So volume strain is equal to change in volume to the original value. So we can write delta V by V. That is the volume strain. We have shearing strain. The strain is produced in any body to the parallel surface. Let us consider a cube. We given the force on the body, there is a parallel to the surface, strain is produced, then the body is said to be in a shear strain. So shear strain is equal to displacement of the surface of the body, displacement of the surface of the body to the original length. So we can also call phi by L. So phi by L is phi is the angular displacement. We can write the tan phi is equal to, there is a change in length to the original length. So this phi by L only we can write in terms of L by L. Tan phi is equal to small l by capital L. This is the equation refers to the shear strain. In general we can write phi is equal to L by capital L. So this is the required equation for the shear strain.